Part B. So using the Newton-Raphson method, we have to write down what we get for x1 and then carry on and do it over and over till we get the root to correct to 6 decimal places. So you get the Newton-Raphson, which is a way of closing in on the root, okay, if you know a value that you're fairly close to the root at. Now, on the previous part of the question, we saw the root was between 0 and 1. They've just chosen 0.8. If they don't give you a choice, you could probably choose 0.5. It wouldn't matter, you'd close in on the correct root anyway. So the formula's in the book. X n plus 1 is x of n, which is your first value, your approximation to the root, which is 0.8, minus f of xn, so that's the value of the function at this value 0.8, divided by f dashed of xn. So the first thing we need to do once we've written the formula down from the formula book is make sure that it's arranged as f of x is equal to 0, which it is in our question anyway. Okay, so we don't need to do anything more to the equation, it's already the way it needs to be. But then we need to differentiate, so we can say f dashed x is 3x squared plus 8x minus 3. Okay, so what we're going to do is use our calculator to help us. We're going to work out x1, which is the next one on from x0, obviously. x0 minus f of x0 over f dashed of x0. So it's 0.8 minus this huge function f of x over the differential with an 0.8 in place. Oops, 8 times 0.8 minus 3. Now, so you don't have to type this in twice on your calculator. This is the way you do it. So you type in 0.8 and press equals, and then you're going to type in this whole thing, but using ants. Okay, so we want ants minus fraction, and then we want ants cubed plus 4 times ants squared minus 3 times ants minus 1. And on the bottom of the fraction, we want 3 times ants squared plus 8 times answer minus 3. Okay, I don't really need the big brackets around it. It's got the minus at the front of the instruction of the fraction. So I'll just check that that looks right, because I don't want to have to redo this. Okay, so if I press equals, that gives me x1, which I'll write as a fraction, or I'll change it into a decimal as well. So that's 0.8616541353. Copy the whole decimal at that point, okay, as it said, but you would copy the whole decimal. Don't start rounding this, okay. We are then just going to keep pressing equals. Okay, because if you've typed in with this answer instruction, the next time you press equals will give you x2. So we're now doing part 2 of the question. And you're going to just keep going. It probably will only take a few steps until you notice it's settled down correct to 6 decimal places. We're nearly there already. Zero 0.857623607. Yeah, so it's not changing now. So I'm going to quite happily round to 60p, and I'll get x4 is 0.857624. And it wouldn't really matter if I'd started with a different decimal in between 0 and 1, where we knew the root lay. Okay, we would have still ended up getting to this 0.857624 decimal anyway. Newton-Raphson generally works well when you start near the root. It can fail if you're further away from the root. Okay, it can diverge, but if it is close to the root to start with, you should find that it works nicely and quickly.